welcome to the pitching session for the hydrogen projects. I'm Pieter Houta and I'll be emceeing. I'm a national contact point for Horizon Europe from the Netherlands. But before we start, I'd like a few house rules. Sadly, it's quite a time-restricted presentation session, so the pitches will be about 4 minutes. For the pitchers, if you go over it, you will be kicked off. Also, meaning questions will have to be asked afterwards, so if you'd like to speak to any of the pitchers, please stick around and find them in this area. For the rest, for the pitchers as well, there is a separate microphone here, and if else, you can stand here. There's a timer on the screen, which is good to have. And for the rest, also use the swap card application to exchange information with those that you want to talk to. But first, I'd like to give the word to the organizers from Widera and GREENET.
So, good afternoon all. Thank you very much for your participation. I'm Miriam De Angelis, the coordinator of GREENET, which is a project founded by Horizon Europe itself. And it is the network of national contact point of Cluster 5 of Horizon Europe. As national contact points of Cluster 5, we organize initiatives like this, aim to spur the networking between mainly Horizon Europe applicants, but also those actors that are working in the research and innovation community, especially those that, of course, focus on Cluster 5 areas. And I would like to remind you, but my colleagues will also go into more details later, that apart from this kind of events, one, of course, is the brokerage event that we organize in conjunction with the EC Info Day of Cluster 5, which is scheduled in spring next year in Brussels. We also have several tools online available for you if you are interested in more partner search, in more networking. We have a partner search platform on our website, but also several other tools, fact sheets and information material that you may browse and download and certainly find useful in your work as a researcher and as, in general, an Horizon Europe applicant. Now, I think I said enough and I leave the floor to my colleague.
Thank you very much, Miriam. My name is Katarzyna Buszkiewicz, and I'm also the coordinator of the NCP project, but dedicated to the widening countries. And some of you used the services that we offer to applicants, meaning the travel grants, but to attend brokerage events and pitching sessions. But I also encourage you to use our another support measure, that is the pre-screening of the project proposals that you submit to Horizon Europe. I will leave some of our postcards informing about the service, and I also encourage you to visit our website where you can find more detailed information. Enjoy the pitches and good luck. Thank you.
Thank you.
All right, so it's starting. I'd like to introduce Magdalena from the Institute of Materials Research from the Slovak Academy of Science. Thank you.
Thank you very much. Thank you so much, organizer, to the opportunity to present this, to selecting my presentation in this session. My name is Magdalena Strečková, and the focus of my work is development of novel catalyst for hydrogen evolution reaction. I come from Institute of Materials Research, what is one of the 45 institute from Slovak Academy of Sciences. In our institute, we have three divisions. I am part of the third division, Division of Functional and Hybrid System, which focus also for catalytic materials for energetics. And we have very strong collaboration with the Faculty of Science, Pavel Josef Jafarik University in Košice, and also all universities from Košice, like Technical University, and we have very close collaboration with the University of Chemistry and Technology in Prague. Our institute is fully equipped with all devices for preparation of catalysts with the different structure. We have laboratories for preparation of catalyst in the fibrous form. It's an electrospinning laboratory, and also laboratories for heat treatment and for microstructure and morphological characterization, and also electrochemical characterization. The main of our goal is the production of hydrogen by water splitting as an alternative of fuel for advanced electrolyzer and fuel cells. And the main task is the development of bifunctional electrode materials for hydrogen and oxygen evolution reaction. And on this picture, I would like to present our best catalysts in the different morphology and form. For example, carbon fibers with incorporated nickel cobalt particles or spherical particles. And only very shortly we are able to study for example, optimization of the process of preparation of fibers or catalysts in different structures. We would like to have catalysts with advanced electrochemical parameters, and after optimization of heat treatment process to the final structure, we studied the hydrogen evolution reaction, oxygen evolution reaction, kinetics barrier inside of systems, and also the electroactive surface area for evaluation of best performance of our catalyst, also the stability of our catalyst for potential application in the electrolyzers and fuel cells. Thank you for your attention, and thank you for my colleagues in cooperation on our project. Thank you.
All right, thank you very much, Magdalena. Next up, I'd like to introduce İpek from Turkey and the EPTA. Here's the clicker, and there's a screen there for your reference. Green, and there's a screen here with your timer and your presentation.
Thank you. I am İpek Terzoğlu Dökmeci from EPTA Turkey. Today I will give you a brief information about our project, development of a zero-gap anion exchange membrane system for green hydrogen production in brazing furnaces. EPTA is founded in 1984 in Eskişehir, Turkey, and specialized in metal in tube forming, atmosphere-controlled furnace brazing, and production compressor lead cables. We are specialized in mainly producing shock loops and discharge mufflers for compressor motors to meet our customers' requirements. Here are some of our sector products, cooling sector products, which includes tube bending and furnace brazing, which our project comes into play because we are using hydrogen gas as a protective gas in our furnaces to prevent oxygen contact. There are another products, lead cables for compressor motors, fully produced in EPTA as well. Currently in our project, hydrogen gas is in our brazing furnaces is either generated from natural gas or ready-to-use hydrogen cylinders, which is not green hydrogen. So in this project, EPTA aims to produce green hydrogen with the design of electrolyzer at 2 meter cube per hour at each furnaces, ensuring high purity hydrogen production which is very important for our brazing quality because high purity hydrogen affects the brazing quality directly, especially in stainless steel materials. Currently, approximately 60% of our electricity is produced from 400 kilowatt solar panel system in EPTA. Remaining 40% is coming from the grid. And the water is used in electrolysis system is planned to be sourced from rainwater. With this project, EPTA aims to reduce its carbon emission levels. In the ionic membrane electrolyzer, the zero-gap design between the cathode electrode and the membrane ensures the high purity, which is very important for our process. The system is cost-effective for industrial use, and it is included automated potassium hydroxide electrolyte preparation with a dosing pump, and conductivity is continuous monitoring in the system. And dehumidifying filters connected to the air dryer automatically activates when the purity declines, while hydrogen purity is monitored with an analyzer as well. And hydrogen pressure is regulated with controllers in each section, and backfire protection is also provided. With this module structure, capacity can be increased according to the scale, and it is ease of service and maintenance. Thank you for your attention. You can contact with us through in our website and LinkedIn page, and you can send an email at info@epta.com.tr. Thank you.
All right, thank you very much, Ipek. Next up, I'd like to welcome Christian from the Polish Geological Institute, and I'd like to ask Professor Salmieh to get ready following this one. Thank you. Keep it close to your mouth. Thank you.
Hi everyone, my name is Chris. I am geologist from the Polish Geological Institute, National Research Institute in Warsaw, Poland. So the problem is how to find natural hydrogen in Poland and how to use this experience in Europe. Why? Because natural hydrogen occurs in rocks just below our feet. It should be considered as an alternative and additional source of the fuel in the hydrogen market in Europe being so clean and so safe for the environment like any other green technologies. So I believe that production of natural hydrogen from geological sources could cover 5 to 10% of the demand in 2030 in Europe. So how to find it and why to start in Poland? Because in Poland we have over 20,000 deep wells. In many of them we found hydrogen. It appears as gas dissolved in groundwaters. It appears as free gas filling the pore spaces and rock caverns. It appears also in our oil and gas fields. For example, the Janinec gas field at the depth 3,000 meters below ground level, we have accumulation of natural gas in which we have 10% of hydrogen. This is pretty much. So, of course, there are many other questions. What is its origin? Why hydrogen appears in different geological horizons, in different rock layers and different places? We still do not know. There are many possibilities. Maybe it is related to generation from the deeper part of the earth. Maybe volcanism, or maybe weathering of different kind of rocks. These issues will be investigated during our two projects realized by Polish Geological Survey next years, together with other scientific institutions. But I would like to emphasize at the moment that we need the cooperation with other European Union partners. We need to collaborate with scientists, with chemists, physicists, geophysicists, biologists, oil and gas industry and government to find and to start the exploitation of natural hydrogen. I believe that this is completely new branch of geology. And I believe that this is an alternative way of renewable hydrogen production in Poland, in Europe, and all around the world. So if you have any question, any ideas related to these issues, please call, write, use the application. I am here today, and at the end I would like to thank the organizers, so GREENET and Clean Hydrogen Partnership, also NCP Wideranet for the travel grant. Thank you guys. Thank you all for your attention, and see you.
All right, thank you for the fascinating presentation. Next up, I'd like to invite Professor Selmiye and then ask Xavier to get ready following this one. Thank you.
So, thanks so much. My name is, okay. My name is Selmiye Alkan Gürsel, so let me go back. Oops, sorry. Okay, I would like to go back. Okay, yeah, great. So, I am Selmiye Alkan Gürsel from Sabancı University. I was working there since 2008. And before joining Sabancı University, I was also, again, working on hydrogen technologies at Paul Scherrer Institute in Switzerland. So, Sabancı University is a foundation university in Istanbul. And it is a top-ranked research university composed of 3 faculties and several research centers dedicated to advancing and cutting-edge research and innovation. And at Sabancı University, we have a robust facilities. We have a robust foundation on hydrogen technologies covering fuel cells, electrolysis, and hydrogen storage. And our facilities support from advanced technologies and approaches, starting from catalyst and membrane development, electrode, novel electrode and MEA fabrication, performance and durability testing, making Sabancı University as a key player on electrolyzers, fuel cells, and hydrogen storage topics. So, our projects demonstrate that dedication. We have been coordinating and participating various national and international projects about hydrogen. And just one of the examples, we are one of the core partners of the first Hydrogen Valley project of Turkey, High South Marmara Hydrogen Shore. In that project, there are 15 partners, and there will be an electrolyzer, 4 megawatt electrolyzer will be installed, and 500 tons of green hydrogen will be produced annually and will be used in different industries, including ceramics, glass, and chemical industry, and also green hydrogen will be employed for power generation as well, and project will be completed in 2028. It was started last year only. And we also have several other projects. For instance, we are one of the, again, core partners of Graphene Flagship project, and we were the task leader of fuel cell task in that project, and we have been involved 5 years in that project to develop fuel cell MEAs in that part. So actually, we welcome new collaborations and are eager to participate in consortiums for the upcoming project calls. So, with a strong foundation on hydrogen, material science and engineering, and also electrochemistry, we can make significant contributions to projects that align with Syria, especially the pillars 1 and pillars 3, which means mainly the electrolyzers, PEM and AEM type of electrolyzers, and also fuel cells, mainly PEM and solid oxide type of fuel cells. So we can contribute for the component and other material facilities. Thank you so much.
Fantastic. Thank you for the great timing. Next up is Xavier from the Spanish CENER, and I would like to ask Tomas to get ready as well. Thank you. Timer, presentation screen.
Okay. So thank you very much for this opportunity. Thank you, GREENET, for having the opportunity to present our technological center. I'm here representing CENER, which is a technological center located in the north of Spain, which is specialized in renewable energy. We have been working for more than 20 years on different kinds of renewable energy, biomass, wind energy, solar, energy in buildings. But today I would like to show you which are we making in the grid integration, electric storage, and hydrogen department. So this department is split in two parts. The first one is called the integration department, and is more focused on the treatment of energy and hybridization of technologies. So for years has been working on hybridization of plants, modeling of systems, development of microgrids, energy management systems, smart management of batteries, and some other kinds, like for example electric vehicles. And the other one that is more recent, that it has about 3 years, it's about 3 years old, is more focused on hydrogen production through electrolysis. We are quite focused on solid oxide electrolysis and solid oxide fuel cells. Now I would like to show you 4 simple examples and how we can contribute to projects dealing with renewable hydrogen production. The first one is focused on the concept green hydrogen. Green hydrogen involves coupling the production of hydrogen with renewable energy, and renewable energy has a dynamic behavior. So we can contribute developing energy management systems for setting the best strategies for adapting the behavior of electrolyzers to the dynamic mode of renewable energy. On the other hand, we have a wide experience on power electronics. We have been working on smart converters and other kinds of converter devices. And we are working on the development of specific power electronics for hydrogen devices, for electrolyzers and fuel cells. That is quite interesting, for example, when we are talking about reversible solid oxide cells. Because in these cases, the power and voltage needs for each part is not the same. So we can have an optimized device for giving the power to such devices. On the other hand, we have, I think it's quite complete microgrid with several types of renewable generation sources and also fossil fuel sources, and several loads that can be used for testing hydrogen devices, once again electrolyzers and fuel cells, reaching 500 kilowatts. That can be used for modeling the behavior when we are integrating renewable energy. And finally, I would like to highlight the work we are doing in the hydrogen area, which is, as I said, is focused on high temperature electrolyzers, and where we are working from the cell, the new materials for SOEC cells, for stack design and manufacturing, and also for the fuel development of systems. So thank you very much. Here you have my details, and I will be pleased to answer all your questions or requests. Thank you.
All right. Thank you very much. Next up is Tomáš from the Technical University of Košice, followed by Blanca. Thank you.
The next is here.
Green, yeah, and here you have a timer and your sheets, so it makes it easier to look here.
Okay. Ladies and gentlemen, my name is Tomáš Brestovič. I am Vice Dean for Innovation and Transfer of Technology from Technical University of Košice, Faculty of Mechanical Engineering. We are focused more than 16 years on hydrogen technology. This time we cooperate with Košice self-region government with project with budget about 9 million euro. We just focused on Hydrogen Valley. We working with the metal hydrides material and creating, together with Slovak Academy of Science, we are creating the new materials, and we working with this material to apply it to hydrogen storage, to compression of hydrogen, or to separate of gases. We create our own first metal hydride compressor, which working with two vessels, and heat is transported between two vessels with a heat pump. One tank is cooled and absorb hydrogen, second tank is heated and desorb hydrogen by higher pressure. This is a student project, and we can testing with this equipment the new metal hydride material to increasing the hydrogen pressure. Of course, it's fully autonomous control, and it's modular system. We can change the part of this compressor. The second part, we created own metal hydride tanks with internal heat exchanger, which is patented, and the external heat exchanger for heating management. We can absorb about 1 kilogram of hydrogen by from 1 to 3 megapascal of pressure. These vessels are fully compatible with standard EM 12322, and we can use this for stationary and mobile application. In mobile application, we use it for creation first Slovak hydrogen bus with low pressure technology. Is cooperation between our faculty and in our partner in East Slovakia, which produce these buses. We can testing these tanks for transportation. It's focused on, and purpose of this bus is using in the public transport. The range is about 180 kilometers. It's enough hydrogen, it's 5 kilograms of hydrogen, enough for 1 day in this public transport. Of course, it is only midi buses for 20-25 persons. This bus was presented in Dubai Expo 2020 in Slovak Pavilion. We have this time the second version. The second version is fully can be used in the driving, because we have a certificate for using. And the last cooperation is a cooperation with Switzerland company, startup company, Sirius Aviation, which can create the flight from 4 to 6 people. And we are designed internal hydrogen system with high pressure, or of course better, is using liquid hydrogen inside. This is the first prototype of one engine. This flight will have about 28 electrical engines. And this is all for my side. This is my contact, and we are here because we can find a new partner for cooperation in the Horizon Europe or another type of the project. Thank you very much for your attention.
All right, thank you very much. Next up is Blanca from the Iberian Center for Research in Energy Storage, or perhaps a colleague. The green button, and then here's a timer, and your presentation here on this screen. Makes it easier.
Good afternoon, everyone. I am David Parra from the Iberian Center for Research in Energy Storage. Just in case, my colleague Blanca is also over there. Thank you to the organizers for the invitation. Let me tell you that being an Iberian Center, we have the support from two different countries, which is Spain and Portugal. And we are a new center, and as such, it can be considered as a new project. Let's see. Here, the message that we want to translate is that we have designed our research interests aligned with the strategic research and innovation which is made at the European level. As a center, we work in different areas and technologies. On the left side of your site, you can see that we focus on the whole hydrogen cycle. So we do research in low temperature electrolysis and fuel cells, where we focus, for example, on anion exchange membrane technology, and we have a strong focus on developing innovative membranes. We also are active in high temperature cells, solid oxide, which are very flexible and, for example, can work in a reversible mode. And finally, from the hydrogen perspective, we also work on storage, and we have a strong focus on solid state hydrogen storage. On the right side, you can see that we couple hydrogen with CO2, and for such, we also do research in CO2 capture. But then, very importantly, we combine both, for example, hydrogen and CO2 towards chemicals and fuels which are very important for society. It could be methanol, SAF, or even ammonia. And we do that following different routes, the more traditional heterogeneous catalysis, electrocatalysis, and also very innovative photoelectrocatalysis. The main message I want to translate in this slide is that our center, the Iberian Center for Research in Energy Storage, is very active in different technology readiness levels. So as such, we do fundamental science, but very important, we are also investing on prototyping facilities and pilot plant facilities, which we are going to see deeper later. And then we collaborate with more theoretical researchers who do modeling, and as such, we model from single atoms and atomistic simulations towards regions and cities. For example, we do CFD modeling and LCIA. And we finish with regulation, which is very important to understand who and where can things be done. For example, regulation is key to implement hydrogen technologies in the energy transition. To finish my presentation, I would like to show you one of our highlights, that is a pilot plant that we are developing in CI. As you can see, we have the different technologies that we work at low TRL levels. We start with an anion exchange membrane electrolyzer of 42 kilowatts. We also have a solid oxide electrolyzer of the same nominal capacity, which is reversible. We incorporate a DAC system to capture CO2 from the air with a nominal capacity of 10 tons per year. We can also physically emulate other CO2 sources over there. And finally, in terms of applications, we focus on methanol and ammonia systems, ammonia synthesis, where we have reactors of different capacities, for example, 50 liters and 5 liters, which are very big for research. Two key messages: there is thermal integration, for example, between the solid oxide and the reactors. And finally, there is a microgrid where we can emulate physically wind and solar conditions up to 2 megawatts. Thank you, and the last note is that we are ready for collaborations.
Thank you very much. Next up, I invite Professor Birol.
Good afternoon, this is Professor Kilkis from Turkey, Ostim Technical University. Ostim Technical University is a special university. It is totally industry-centered. We have about 5,000 companies all around us. So it appeals for every discipline, including the so-called our project here, green hydrogen-fueled UAVs, unmanned, actually it is unpersoned because unmanned is a gender problem. we call it unpersoned aerial vehicles, and hovering land assets for wildfires and reconnaissance, forest fires, which is very important today. And my contact lines are here and are available around. So what is the special project? This is a complete project as highlighted in the above equation. We have a new definition, fire suppression index. And normally the existing firefighting airplanes or helicopters or even UAVs have low fire suppression indexes. In our case, it has about more than 60 and 70 kilowatt per meter. This is the equation. And about green hydrogen, I have a short note. We actually name it as nearly green. Why nearly green? Because every process has some exergy destruction according to the second law of thermodynamics, which is loss of useful work potential. Even take photovoltaic PV cells. They reject the heat that they absorb, which could be used. So unless you use a PVT, PV is responsible for some carbon dioxide emission responsibility because someone, somewhere, sometime has to offset that. So it is nearly green. That's the system. Thanks to hydrogen, it has different assets, different prongs. For example, it uses hydrogen which has been prepared on the ground, put in cassettes, and it has a certain amount of water suppressant. But the technology innovations here are as follows. The fuel cell first depletes the oxygen right above the forest fire to generate electricity using hydrogen. And also water. We don't just reject the water. This is very special, which is very precious, and we use this water by cooling it to an adsorption heat cold machine where the heat comes from the fuel cell, the waste heat. So we don't waste anything. So colder the water, better the fire suppression, and we also put nano hemp particles which has very high specific heat, and they also help in firefighting for forests. And as a last resort, if the fire doesn't go away as planned, we just drop the hydrogen tanks just to circumvent the fire. So it's a multi-purpose. And this is the idea, and we have also ground assets here, which are also running on hydrogen. They have tracks that can climb, or they can hover as a hovercraft, hydrogen driven, and they also have a combination of systems, as written here and as shown. It is a multi-dimensional control system, and this control system orchestrates everything. So these are the items, main attributes are listed over there, but I think my time is up, and thank you so much.
Thank you very much. Thank you. All right, thank you very much. Next up, but I haven't seen him yet, I would like to welcome Leo Janssons. Do we see him anywhere here? There we go, perfect. From the Riga Technical University. I'd also like to ask Dean Viduka to get ready following this presentation.
Okay, thank you.
There's a timer here and your presentation.
Yeah, absolutely. Hello, my name is Leo Janssons, and I'm representing Riga Technical University. In fact, there is quite a big consortium of stakeholders behind our university. There is also colleagues from Latvian University, from Latvian Academy of Sciences, many industrial companies connected to energy and transportation, and also quite a few NGOs. Actually, I myself, I'm coming from the gas engineering part of the mechanical and technical engineering spectrum, and currently I'm the PhD candidate and the researcher at Riga Technical University, and I myself and the group I represent, we are mainly focused on these areas of research and regarding the renewable gases, including green hydrogen. This is mainly the area which connects urban living, urban environment, and use of renewable gases. It's quite a big issue in our country, Latvia, I represent, that there have been quite a significant investment done in gas infrastructure, especially distribution gas networks in recent 15 to 20 years. And we, of course, would like to keep this infrastructure intact, and even then, when demand for natural gas will be going down significantly, and it is even now going down. And of course, in this situation, blending hydrogen with natural gas and biomethane, it's a big issue, and we see it as one of the ways how to decarbonize urban environment, both in transportation sector and power generation and district heating. So of course also we are mainly working with mathematical modeling methods of advanced decision making and digital twinning. So yeah, and this is one of the projects in last 10 years. Our group has been a part of more than 10 both international and high-level national projects. So, and this is our recent one, which is dealing with decarbonization of last-mile deliveries in Latvia. Actually, quite a pressing issue because most of these deliveries are deemed to be carried out with fully electrical vehicles, and we would like to also bring hydrogen into the urban environment and not to exclude it from these deliveries. And there are possible areas of research where we could contribute if would become a part of some research project or consortium. And actually, yeah, mostly these things are related to urban area and decarbonization of urban energy supply systems at different levels and different complexity using renewable or green gases, hydrogen and biomethane. So, thank you very much, and if somebody have some questions or interest about these issues, please contact me. Thank you.
All right, next up is Tin Viduka, followed by Marta. Thank you. The top green button. Or the next slide. Next slide. Keep it close to your mouth. Timer. Presentation. Good luck.
Hello, my name is Tin Viduka from company Alpro Croatia. Today I'll be talking about hydrogen locomotive retrofit, meaning exchanging the propulsion system of a diesel locomotive with hydrogen propulsion. First, a few sentences about the company. We are an SME from Croatia, specialized in research, development and production of safety and signaling related equipment for railway infrastructure and rolling stock. Today is the topic of rolling stock, so I will be focusing on this area predominantly. In rolling stock, we produce, of course, safety and signaling related safety equipment, but also we are dealing with preventive and corrective maintenance of the same locomotives. which is one of the key enablers for us to be able to engage in activities like exchanging a locomotive propulsion system. The company itself is more than 30 years old. We exported our products to more than 50 countries. The company is 100% privately owned in Croatia, and we currently employ more than 200 people. Why would someone retrofit a locomotive from diesel to hydrogen? We are getting, let's say, the best from both worlds. We are getting the flexibility and versatility of diesel locomotive, meaning that we can run on the whole network without the restriction of overhead line equipment, the power supply for electric locomotives. But on the other hand, we are getting the high capacity performance and the green footprint of a typical electrical locomotive. Again, we are getting an additional solution for decarbonizing the transport, which is in the focus of all of us. We are getting the alternative to decommissioning older diesel-powered locomotives, since we can prolong their life expectancy with exchanging the propulsion system. We're getting the zero emission, which we are all aiming for. We are getting also the cost-efficient solution for non-electrified track, since electrification is quite expensive all over the world, not just in Europe. We're getting the lower maintenance cost and, of course, less noise and vibration, which benefits the users of the said locomotives. What are we as a company doing here on this conference, on this Hydrogen Week? We are looking for potential partners for the following critical areas of such a project. Of course, we have hydrogen tanks, high-capacity hydrogen tanks class 3 and class 4. We have fuel cells where we require also integration support, since it is we are talking about a prototype. Of course, we'll later on scale it up to a serial production, but right now the concrete project is the prototype. Then batteries, which are working in sync with fuel cells, converters, and locomotive control system, since every locomotive has its own, every series of locomotive has its own control system, and we have to adapt it to a new propulsion. We'll be around for the next 3 days, so if you have any questions, feel free to contact me anytime. Thank you.
All right, last but not least, I'd like to invite Marta. You have a timer here and your slides right there.
Welcome everybody. My name is Marta Żurek-Mortka. I'm from Łukasiewicz Research Network, Institute for Sustainable Technologies, located in Radom in Poland. I represent the Department of Control System. And today I would like to say some about the water circular economy in hydrogen installations. Because, as we know, as I can say that previous solutions that presented partners are very interesting, but the most important issue is related to water. Water, as we know, within next years can be a critical source in our world. So our idea is a concept, the preparation of system of water circulation and preparation system and for electrolyzer supplied from renewable energy sources, because we have to obtain the green hydrogen, not any other one. So we propose to develop a water preparation system of appropriate quality intended to power the electrolyzer and the hydrogen storage system. And this one, it can be a multi-stage water purification system or less steps. So this laboratory hydrogen installation can be include following systems, for example, receiving hydrogen from the electrolyzers module, compressing hydrogen, and storing as well as generated electricity from using fuel cells. So the parameter of each individual systems will be specified, taking into account the scalability and, of course, for the solution adopt. So it can be possible to obtain the water circular in energy hydrogen installation. So it can be, the looks like here, as you see, the first one. The most important is source of water, not tap water, not water what you can drink it. It can be from rain, sewage, and any other, for example, post-consumer processing. With these parameters, as you see, so then next to the water preparation system, it can be a multi-stage system and go through to the electrolyzer and hydrogen compression storage system and fuel cell. And you see that one of the product of fuel cell can be water, and we reverse this water to this system at the first stage. How I can say about our experience and expertise, we focus on, among others, the design and implementation of different microprocessor systems, including real-time strict system and any others. For example, technological process control system, this is supply systems, and our laboratory include the different devices and equipment such as those in field of programming engineering, microprocessors, and any others equipped with SCADA and HGM systems tools. Thank you so much. My name is once again Marta Żurek-Mortka, and if you have any questions about these systems, and of course, I encourage you to get know more about this. Thank you so much.
All right, that's our last presentation for today. Just a few closing remarks. Thank you so much for everyone who pitched today. It takes a lot of work, despite it only being a 4-minute presentation. You have to travel here from abroad, and it was a relatively competitive process to actually be part of this pitching session. So I invite you all to take some time, discuss with some of the speakers, and really dive deep. But how do you do that as well? One thing I'd like to highlight is the National Contact Point Network. NCPs, raise your hand. I see a few national contact points, mainly here. I see one there as well. What we do as national contact points is, of course, Horizon Europe is a bit of a difficult thing to enter, but we help with proposal advice. We help with the forming of a consortium, as well as communicating with the EC and representing you as member states towards the European Commission. Finally, I'd also like to thank the backstage, Ines. I don't know if you're there, but thank you for doing this. Thank you to GREENET and Widera. And I'd like to invite the pitchers to come up for a group picture in a few minutes. Thank you very much.